So there are various management activities which can be divided into general management, marketing management, sales and distribution, accounts and finance management, human resource management, and operations management. Most of these management activities we will include in this, we have included in this course, and we will teach you. In previous lectures, we talked about general management. Now we are shifting to operations management. Operations management include core operations of the institute, firm, or a business entity. Here it is a clinical laboratory. So operations of clinical laboratory we will teach in various headings, including capacity management, inventory management, equipment management, and others we already know the how to perform tests. Those are also operations, but we will not teach in this course. We already know that. So we will teach you the management concepts. So today I'll talk about capacity management. So there is one small story. One fine day, someone in the headquarters of MCD thought that we can increase the revenue of MCD by increasing the workload on the clinical laboratories of the MCD hospitals. So they directed us to calculate the capacity, existing capacity of the clinical laboratories associated with the MCD hospitals, including Indora Hospital. So we calculated the capacity, and we found that we are working at about 50 to 92% level of our capacity. So should we work at 100% level? And what is the capacity? All this we learned today. This is my lecture outline. First, I'll talk about production decisions. Then I'll talk about what is capacity, then dimensions of capacity, then capacity planning, then capacity management, then operational level of capacity, then capacity model. Then I'll describe certain calculations, and we will do 2 exercises today to learn about capacity management. So production decisions can be divided into 3 levels. One is strategic level decisions. These are top level decisions which are taken by top level managers, and the time horizon is although variable, but it is usually more than 3 years. Then there are tactical decisions which are taken by middle level managers, and time horizon is about 6 months to 3 years. Although time is variable, then there are operational decisions which are supervisor level decisions which are usually less than 6 months. And in production industry, these are the various management activities. So at strategic level, there is capacity planning. And for capacity planning as well as aggregate planning, then MPS and MRP. MPS is master production schedule, and material resource planning. For these, we need demand forecasting, and demand forecasting can be both long-term as well as short-term. So for capacity planning, we need a long-term forecasting, and it is a strategic level decision. So what is capacity? Capacity is the ability to hold, receive, store, produce, or accommodate raw materials, finished products, or customers, etc. And goal of capacity management is to achieve a match between long-term production capacity and long-term demand. So this is our goal of capacity management. Types of capacity, there are 2 types of capacity. One is design capacity, also known as installation capacity. It is the maximum capacity of the section of a laboratory, and the second is effective capacity or system capacity. So if we take an example of a 5-part hematology analyzer with a throughput of 60 samples per hour. So in a daytime working of 6 hours, it can run up to 60 into 6 number of samples, but that is the design capacity. Usually we divide our working day into number of shifts or batches, and the effective capacity is always less than a design capacity. And the effective capacity depends on actual demand and resource limitations. Resources include raw material, labor constraint, power constraint, and time constraint. For example, in case of metrology analyzer, usually analyzer runs for 2 to 3 hours in a total 6-hour working day period. Then dimensions of capacity. These are the dimensions of capacity. One is quantity, that is how much capacity is needed. Then timing, when should capacity be available? It depends on the forecast, future forecast. Then quality, what kind of capacity is needed? Kind of capacity, by kind of capacity, we mean either manpower or the equipments or other raw material. Then location, where should capacity be installed? Capacity planning is a long and short-term strategy. It is a process to determine how much capacity is needed, when it is needed, and what kind of capacity is needed. Kind of capacity, we have already seen that it is in terms of manpower, machine, or material. Capacity planning is described as a tool to minimize the discrepancy between the capacity of a business entity and customer demands. Strategic capacity planning is an approach for determining the overall capacity of capital-intensive resources, as we have seen, facility, equipments, and manpower. Then these are the various strategies which we can adopt while running our business entities or a clinical laboratory. We can adopt a lead strategy where we increase the capacity before the anticipated increase in demand. Then second is lag strategy, where we increase our capacity after the demand has been increased or decreased. We can also decrease our capacity. Then the third is match strategy or adjustment strategy, where we do small increments as demand increases or decreases. Then procedure for capacity planning. These are the various steps. First of all, we assess the existing capacity, which we can do by input method or output method. In service industry, we do by input method. Then we require forecasting. Then we identify various alternatives. I'll talk about various alternatives in my next slide. Then we evaluate those alternatives and we select the most suitable alternative, and thereafter we monitor the results. So these are various alternatives which are available to manage the capacity. These are to increase or decrease the capacity depending on the demand. So these can be divided into long-term as well as short-term. In long-term strategy, we can upgrade our machine or we can purchase a new machine. We can expand our existing plant or facility, or we can create a new plant in a manufacturing industry. Then we can change the manufacturing method, and or we can develop a new product by which we can utilize the existing capacity. To utilize our existing capacity, we can develop a new product, or for example, in a clinical laboratory, we can start doing a newer test in our existing machines to justify our capacity. Then short-term alternatives for capacity management include we can have more manpower to increase the capacity, so we can hire the manpower. But here we incur the recruitment and training costs. Then to decrease the capacity, we can fire some of our workers, but the disadvantage is it can lead to technology transfer and bad image of our clinical laboratory. Then we can subcontract, we can outsource the test, we can also do overtime, and we can also add additional shift to our duty hours. Then these are other alternatives. These are the newer alternatives. We can optimize production layout. We can reduce machine downtime and with total productive maintenance. So maintenance, as we will learn in equipment management, are the reactive maintenance and preventive maintenance. So by machine maintenance, we can reduce the machine downtime. And we can use lean manufacturing techniques, and we can also maximize the capacity utilization. I'll talk about capacity utilization later. Then what are the factors affecting capacity planning? These include level of demand, availability of funds, then human factors, which include employee training, experience, motivation, absenteeism rate, and leadership style of manager. We have learned about leadership style in our previous lecture. So these are the human factors which affect capacity planning. Then there are external factors like level of competition in the market, then government policies on pollution control, safety requirement, and the technical factors of the country. Then size of facility and operational and management factors are other factors which affect capacity planning. Then what are the benefits of capacity planning? By planning the capacity, we can meet the future demand. It helps in preparing the budget because we know beforehand our requirement of manpower, machine, and raw material. So it helps in budgeting. Then we can monitor the cost as both excess and lack of capacity are costly. And by capacity planning, we can have competitive advantage and it has an impact on long run. So capacity management involves adjusting the capacity of a resource to meet the planned load or demand. It is also used for budgeting and planning purpose. So capacity management is a broad term and capacity planning is a small part of capacity management. Capacity management is include also day-to-day management, whereas capacity planning is a beforehand plan. So capacity management include monitoring, analysis, tuning, demand management, and capacity planning, which we have seen. These are the benefits of capacity management. Then a little bit about operational level. So there is a concept of economies of scale and diseconomies of scale. As we increase the volume of our workload, there is reduction in the unit cost of the output or the test results. But if we increase the volume more, it will be more costly because of diseconomies of scale. These are two principles of management, economies of scale and diseconomies of scale. So there is an optimal level, which is the lowest part of this curve, which is the best operating level. So we should not be operating at the full capacity. Why? Because when production is rushed, there is a strain on resources, quality is affected, we have overworked and stressed employees. It seems demotivating if it is continued for long. It results in loss of sales figures. We are unable to meet unexpected increase in demand because we are already working at full capacity. So we should not be at full capacity level. And production equipment will require periodical repair and maintenance. They will require more number of repair and more maintenance if we are working at full capacity. So this is the diagrammatic representation of same. Ideal scenario is scenario 1. We should be working at this scenario. Scenario 2 is working at full capacity. And scenario 3 is, it should not happen because we should do a capacity planning and the future demand should not be more than our capacity which we have planned. Then there is a concept of capacity model. Capacity model is a visual representation of confirmed workload versus capacity. So we have various softwares available in market which we can use for our capacity model generation, and we can see the real time as well as planned picture of our workload as well as the capacity. So the capacity model is built using following information: type of machines, tools needed to build a product, number of machines available, output in terms of quality of product or services. There are two types of capacity models, static and dynamic. Now certain calculations. So there are basically two types of activities in any firm or any business entity, and for example a clinical laboratory. One is where the task is people oriented or a task is machine oriented. In people oriented tasks, we need to plan the capacity of manpower. Whereas in tasks which are machine dependent, more machine dependent, we need to plan the capacity of our equipments. And for these calculations, we proceed like this. For people, we calculate the working days minus holidays, minus absenteeism, minus other losses. That is when a worker goes for training or he or she is absent. So we calculate the available capacity of human resource or manpower of our business entity. In case of machine, we calculate the working days or machine availability. We subtract the planned stoppage of our machines. Then we subtract the planned maintenance duration from the available working days and unplanned stoppage. So then by this we calculate the available capacity of our equipment. For manpower, there is a term known as standard minute value. So it is a time a skilled worker required to complete a specific task while working consistently and efficiently using prescribed tools and equipments. I will give you an example, an exercise to make it more clear. Then availability, machine availability is a percentage of time that machine is actually producing. So for example, let us pick a machine that does not function due to mechanical failure 10% of time and is in setup 5% of time. So it will be available for 85% of time. Our hematology analyzers, they take about 3 to 5 minutes during setup when we switch on the analyzer. So we need to subtract those setup time and those failure time to calculate the availability. Then this is units produced per hour. This is the average number of units produced per hour. Then, for example, for hematology analyzer, a 5-part hematology analyzer usually have a throughput of 60, that it can run 60 samples per hour, but that is the maximum capacity. Then time needed per product, the number of units of products to be produced divided by units per hour. So to run 120 samples in a hematology analyzer, we will require 2 hours. For an analyzer with a throughput of 60, so we will require 2 hours. Then hours available for a machine per bucket time. So it is equal to number of working hours in a day multiplied by number of days in time bucket multiplied by machine availability. So loading, that is the operating level. So operating level is equal to PT divided by the hours available. I will give you an example soon. Then there is a term known as capacity utilization rate. It is equal to actual output divided by the design capacity. As we have seen in our example of hematology analyzer, in a daytime of 6 hours with a throughput of 60, the machine or analyzer can run 3600 samples. But normally we have only 2 shifts. Machine runs in for about 2 to 3 hours. So that 2 to 3 hours is the actual output divided by the design capacity is the capacity utilization rate, and we calculate it in terms of percentages. So to increase the capacity utilization, we need to raise the demand or lower the capacity or increase the efficiency. By these, we can increase the capacity utilization rate. Then efficiency is the actual output divided by the effective capacity. By effective capacity, I mean the systemic capacity. It is not the design capacity. Then production capacity is machine hour capacity divided by cycle time. And where the machine hour availability, we have already seen the formula. And cycle time is time required from raw material to finished good. For example, for a hematology analyzer with 60 samples throughput, it requires about 1 minute. So cycle time is 1 minute for a hematology analyzer of a throughput of 60 samples per hour. The number of machines required, we need to calculate the number of machines required in future. So it is equal to cycle time multiplied by demand divided by hours availability. And cycle time, as we know, is the raw material to finished good, that is in a laboratory to run a particular test. And hours available, we have already seen. This is the formula for our hours available for machine. Then capacity quotient is the 100% of the capacity minus the capacity utilization. So it is the buffer which we have in case the demand suddenly increases. So it is a buffer which we have, capacity quotient. So we should have a quotient. This is an example which I have taken from actual scenario in our laboratory. So if we have a machine or hematology analyzer which is available for 90% of time, because 10% is breakdown and setup time. So 90% of time our analyzer is available and throughput of analyzer is 60 samples per hour. So time needed per product, that is TN, with a demand of 200 CBC samples per day is 1200 divided by 60 or 20 hours. So this is the time which we need. Then production time needed for each machine is 20 hours, and hours available for a machine per time bucket is 4. Time bucket here is 6 days. So 4 hours per day multiplied by 6 days multiplied by 90% is 21.6 hours. So total loading that the operation level, we are operating at a level of 92.6%. Here 200 CBC samples per day, and for a 6 days, it comes out to be 1200. So this is about calculations, and this is important calculation because this will be used in our next exercise. So exercise 1. So question is, how many automated hematology analyzers are needed to satisfy a future demand of 500 samples per day with following additional information? All samples come before 10:30 a.m. in a day. In a day shift of 9 to 4 p.m., the analyzer will run for 3 hours in afternoon in a single batch. Machine throughput is 60 samples per hour, and machine downtime is 10% of the, and machine startup is 5 minutes. So startup time of hematology analyzer is 5 minutes and machine downtime is 10%. So now you calculate, each one of you please calculate the number of hematology analyzers which are required.
So all of you take a piece of pen and pen, and let's do some maths.
So this is the answer. Availability is 90%. That is 90% of 3 hours. We subtract startup time of 5 minutes from this 162 minutes. That is 157 minutes. We have available for a particular day, and throughput of our analyzer is 60. So time needed to test 500 samples is 500 divided by 60, or 8.3 hours, or 500 minutes. Whereas the time available was 157 minutes for a single analyzer. So number of analyzers required are 500 divided by 157, or 3.14. And that means that we need 4 analyzers to complete the task of 500 samples per day. So very good. All of you have done nicely. So this is an example of a task which is, machine dependent task, where the work is predominantly done by an equipment or machine. But sometimes there are tasks in a clinical laboratory where the manpower of worker is more important, whereas the machine or tool is less important, and the rate limiting factor is the manpower in that scenario. So we have another example for that. So the question is, for the following year, how many histopathology technicians experienced in microtomy are needed to satisfy a future demand of 80 paraffin blocks per day with following additional information? Demand is uniformly distributed throughout the year. We assume 240 working days in a year in which sample comes. In a day shift of 9 a.m. to 4 p.m., microtomists work for 1 hour in morning and 1 hour in afternoon, as it is a tiring job. Microtomy is actually a tiring job. So microtomists work for only 2 hours, 1 hour in the morning and 1 hour in the afternoon. And standard minute value, which we have seen in our previous slide, definition of standard minute value, is the amount of time required to complete a particular task by a trained manpower efficiently. And for microtomy, it is about 1.5 minutes per block. Then efficiency of microtomies is 90% and absenteeism rate is 5%. So now you calculate how many histopathology technicians for microtomy are needed. Here the task is the worker dependent. Microtomy is not important, it is the microtomist which is important for this task. So this is the calculation. So we have a demand of 80 blocks per day for 240 days. So we have a total of 19,200 blocks in the following year. And standard minute value here was 1.5 minutes. So total time required for fulfillment of demand was 28,800 minutes. And our capacity per day, the formula is number of workers multiplied by shifts hours multiplied by 60 for minutes multiplied by efficiency in terms of fraction. So it will be divided by 100. Then we subtract the absenteeism here. So it is 1 minus absenteeism in terms of fraction. So 1 minus A by 100. So this is formula for capacity. So we have a capacity of 24 6 to 4 minutes in case we have one microtomist. So number of microtomists required here is 1.17. That is 2 microtomists are required to fulfillment the demand of 80 blocks per day for the following year. So this is how we actually plan the capacity of our clinical laboratory, and we have seen the example of machine oriented work as well as the manpower oriented work today. So thank you.